Good morning. I'm Maria Roig. I'm working at CSIC, and I would like to help you to answer this question: how old is water in a Mediterranean mountain catchment? This is a chapter of my thesis. So we often seen this picture at school, the water cycle, right? We know that water evaporates from the sea, it moves through the atmosphere, it condensates, it falls like rain, it infiltrates to the ground, and it goes back to the sea. So there is a cycle. And what I'm interested on is to calculate the time that water spends traveling through the ground. That's called the water age. And why this is important? Because it lets you know how the ground works, how the ability of the ground to retain and release water, and to know, for example, how long your pollutants would be in the ground, which is really interesting. First, you have to know how the catchment works, and after that, you can work in other things. So to do that, we're working with stable isotopes, tritium, and other traces, that what they give you is the water age. The basic idea is that you know the concentration of your traces in rainfall. You take samples of rainfall 10 years ago, and you know a concentration of these traces. Later, 10 years later, you take another sample, you stream, or in your well, or in your spring, and you have a concentration. If this concentration you took later, it's the same concentration of the rainfall you had 10 years ago, it means that your sample, it's 10 years old. It had fallen 10 years ago. This is the basic idea, and now the tricky things are coming. So one of my objectives is to calculate the water age of spring water, wells water, and stream water in Vallcebre research catchment, which is located in northern of Catalonia at 90 kilometers from Barcelona in El Berguedà. It's a catchment of 4.2 kilometers square. There we have installed hydrometric monitoring, and we sample water of rainfall, stream water, groundwater, and spring water. And now I'm going to explain you more tricky how we calculate the age of the water. First, in my group, we choose three traces. Stable isotopes, which are, okay, I don't have laser, which are oxygen and deuterium. They are useful for waters younger than 4 years. But we also wanted to calculate if we had water older than 4 years. That's why we choose tritium. Once you have the concentration of your traces in the rainfall, you have the concentrations of your traces in your samples, you apply this convolution integral, these mathematical things, and you extract from this formula the water age. First, you have to decide which is the model which describes how your water moves through the ground, and this is quite tricky, and later on to select which is the best model that fits your data. And for these things, we use statistics. And the basic idea is that you design a model that tries to fit your data. Your data are these red dots that we have in the graph, and you design a model that should fit perfectly in your samples. And if it fits perfectly, from the formula, you can extract your water age. And the results we got in Vallcebre is that with the three traces we've been using, our water is older than 2 years, and that spring water is the oldest water we have, and the youngest water is groundwater of 3 years. So the conclusion is that in the catchment where we work, the youngest water is groundwater, the oldest spring water. That doesn't matter which tracer we use because similar results were obtained. And that's it. Thank you for your attention.